Okay, so in this video, we are going to answer a question that came in 2017 paper 1 GCE, that is Addma, and the question was question 12. Right, so the question says the diagram shows a circle with center O of radius 5 centimeters. So you take down the points that you're given. Radius that you're given is 5 centimeters, and we're also told to say ACE is an isosceles triangle such that the adjacent sides AC and CE are tangents to the circle at B and D respectively. Then angle ACE is pi over 2 radians. We are told to say that angle ACE is pi over 2 radians, and in other words, pi over 2 radians just equals to 90 degrees. Alright, that's the simple language. So the first question says find the perimeter of the shaded area. Alright, so we have this diagram here, and this is the shaded area that we have, and we have been asked to find the perimeter of the shaded area. So imagine if this area was also shaded, it would have been easy for us to just find the perimeter of this whole triangle, then you also find the perimeter of this semicircle, then just subtract. But in this case, this part is not shaded, so we're only taking into consideration this part and that part. And if you look closely, we hide this part and the other part on top there, we say we cover this up. We say cover this up and we cover that up there. So we find that we have that shape there, which is in form of a trapezium. All right, so you can find the perimeter of the trapezium and find the perimeter of this sector that we have inside, then we subtract it from the total, then it means we have arrived at the answer. So here I'll use this sheet to make some solvings of some figures that are not yet there. For example, if you look at from this point to this point, we have 5 centimeters, and from that point to that point, from OD and OB are also 5 centimeters, because they are more like the radius. They are adjacent, and they touch the circumference of the circle from the center. Then from this point to that point, we don't have yet, it's not 5. 5 is from this point to the circumference of the circle, but there's this small distance that is here. So how do we go about finding such? All right, so we take into consideration to say here we have 5, and if we have 90 degrees here, meaning here we have 45. Right, at this angle we have 45, and at this angle what we have is also 45, because this is a right angled triangle. All right, sorry, I've been told to say this is an isosceles triangle, and this angle that we have here is 90 degrees. So here we have 45 and here we have 45. Okay, so if here are 5 and the angle that I have here is 45, it's easy for me to find the side that is here and the side that is there. So now we'll start by finding the side that is we say we find the adjacent first. So it's more like we have something like this. So to make your work easy, you can take apart all the triangles that you have to make your work easy. So here we have 5 and here we have 45. And remember, this is O and B and A. That is this is that right there. We're going to find the distance here and there. So remember to say we have the opposite here, we have the angle, we're looking for the adjacent. So in this case we can use tan. We say tan 45 is equals to opposite, which is 5, divided by adjacent, which is AB, or we can say BA. So now we are saying it's more like we are making AB the sub of the form. We can say AB is equals to 5 divided by tan 45. All right, so what is 5 over 1? Tan 45 is just equals to 1. So here we're going to have 5 centimeters, meaning even here we also have what? 5 centimeters. So now it becomes easy for us to find the other side, because you can either use SOHCAHTOA again, or you can use Pythagoras theorem. So now we can say AO is the hypotenuse, so you can say AO is equals to square root, we say AB squared plus BO squared. All right. So here we can have 5 squared plus 5 squared. We have 5 squared is 25 plus 25. And we have 50 right there. Then the square root of 50, you can seek the help of a calculator. You're going to get something like 7.07 centimeters. All right. So meaning here we have 7.07 centimeters. So meaning for if you look again, BO and CD, they are the same. Even here you have 5. Then OD and BC are also the same. We have 5 centimeters there. Even here we have also found 5 centimeters. Meaning we have the distance here 5, here 5, here 5, and here we have 5. Then from this point to that point we have 7.07 centimeters. Okay, so that's what you get when you do it from your calculator. You say the square root of 50, you're going to get 7.0711 and whatever. Yeah, but just round off to 2 decimal places. So we have found the distance from that point to that point, so which makes our work easy now. So it's just a matter of diving in the solving. So now we say, remember I said we find the perimeter of the trapezium. So we say perimeter, in this case I just say trapezium, I just say trap is equals to, so remember we have 5 plus 5 plus 5 plus 7.07 plus 5. So we are saying 5 plus 5 plus 5 plus 5 plus 7.07, of which you are going to get 27.07. Yeah, if I'm not mistaken. So in short I'll just say 5 by 4, 20 plus 7.07. Yeah, that is 27.07 centimeters is the perimeter around the trapezium. Okay, so now what is remaining for us to find the perimeter of this sector that is inside. So now we say perimeter, I'll say sector, I just say sec, say is equals to, so remember how you find the perimeter of the sector. We say theta divided by 360, you multiply it by 2 pi r. Then you're also going to add the 2 sides that you have at the end. All right, remember, if you don't want to say 2 pi r, you can just say pi d. It's still one and the same thing. Okay. So the angle that we have here is, want to find, for you to know the angle that is here, you know, to say from this point, this angle that is here is 90 degrees. So now the question is, what angle is here? So again, here it comes back. Here you have 90 degrees, and here you have 45, and here you have 90 degrees, meaning even this one is also 45. So just a matter of you adding this 45 that is here plus this 90, giving you 135 degrees. Divided by 360 multiplied by 2 times 3.142 by the radius, which is 5. Okay, so we say 135 by 2 by 3.142 by 5. We are getting 4,000. Okay, we are getting 4,241.7. We divide by the 360 that we have. Divide by, okay, 135 by 2 by 3.142 by 5. That is that. Divide by 360. Right there. So what you're going to get is 11.7825. So remember to say this that you have found is not the total perimeter of the sector. It's just the distance from this point to that point. Now you have to add this point, this distance, and that distance, because you're talking about the distance around a given figure. Okay, so you just add, we say plus 10, because why am I saying 10? You have from this point to that point you have 5, and from that point to that point you have 5. Okay, so here what you're going to have is 11 plus 11.7825 plus 10. You're going to have 21.7825 centimeters. So that's the perimeter of the sector. So now we just subtract this from that. So I say minus 27.07. Okay, so we say 27.07 minus 21.7825. I'll round off this at last. So what we're going to have is 5.2875, which if you round it off, you're going to have 5.29 centimeters as the perimeter of the shaded area. Shaded perimeter is 5.29 centimeters. So that's how you go about finding the perimeter of the shaded area. Then again, next part is asking us to find the area of the shaded part. Okay, so again, at least we have already done something that is going to make our work easy. We have already found the distance from this point to that point. So now we're also looking for the area of this shaded part. So it's easy again. Just find the area of this trapezium, then find the area of the sector that you have inside there, then subtract. It's as easy as that. So now what we are going to say is that we first of all find the area of the trapezium. We say area of a trapezium is equals to 1/2. Then here you have A plus B multiplied by the height. All right, now what are the values of A and B in terms of the trapezium? The A that you have, remember to say we are ignoring this part. We are ignoring this part and this part as well. Our A is from this point to that point, meaning from O to D. And O to D we have 5. So we say 5 here plus. Then B is from this point to that point. So you have 5 centimeters here and you have 5 centimeters, giving you a 10. Right, multiplied by the height. And the height that you have is from that point to that point, which is also 5 centimeters. Okay, so meaning here you are saying 1/2, you have 15 by 5. Okay, this will give you 70 something, 75. Okay, just seek the help of the calculator. We say by 5, giving us 75 divided by 2. So we say divide by 2. What you're going to get is 37.5 centimeter squared. That is area, so we need to give it in centimeters. Okay, so now we have found the area of the trapezium, and remember to say this sector is inside the trapezium, so it's just a matter of you finding the area of that sector, then subtract it from the total area. I'm just relate it here. I say 37.5 centimeters squared. Right, then this is the area of the trapezium. Then the area of the sector, we say area of, say, sec is equals to theta over 360 multiplied by pi r squared. Okay, remember the area of a circle is, you find it using pi r squared, but we are adding the theta over 360 because we're not finding the whole circle. Hence there is a certain angle that is just a part of 360 that is gotten, that we need to find in this case. So here we say the theta that we have is still 135 divided by the 360 by 3.142 by 5 by 5. Okay, so now we say 135 by 3.142 by 5 by 5. Okay, we have 10,604.25. So we have 10,604.25. We divide it by 360. Okay, divide by 360. Okay, what we are going to have as the answer is 29.45625 centimeter squared. Remember, this is the area of the sector inside there, so just subtract these from what we have here. So hence we are going to say we are going to say 37 point, I think, let me just write it here. Okay, so we have 37.5 centimeters, the area of the trapezium squared, minus we say we have 29.45625. Okay, 20, subtract 27 from 35.5. Sorry, not 27, I meant 29. Okay, so I say 37.5 minus 29.4 0.45625. What you're going to get is that we're going to get 8.04375. You round off this, we're going to get 8.04 centimeter squared. So meaning the area of the shaded part is the area of shaded is equals to 8.04 centimeter squared. So that's how you go about solving that question. And solving such questions that deal with shapes is kind of it's interesting, because you are free to take like everything apart, then put it in smaller forms. And let me make an emphasis here: when you are finding the area of this trapezium, sorry, the perimeter of this trapezium, don't find the area of this small one and that small one, then you add them together. It will be you find like it will bother you a lot. It bothered me at first when I was trying to figure out how to do this, because I was finding this and that, then I add them together. But the mistake I was making, that I was including the line, that it meant I was including the line on the line on the middle. But perimeter means just the distance around a given figure, not in the figure, but around a given figure. Yeah, so that's how you go about solving that question. Thank you.